So, what happens next? We've made our compound and we want to know what's going to happen. And I said it depends on whether you work in acidic, basic, or neutral conditions. Well, there's two things that can happen. We can get the aldol addition reaction, which is where we form this happy little alcohol here, or we end up doing what's called the aldol condensation. And the aldol condensation results in this OH group disappearing, and we end up forming an unsaturated ketone. So two options here. Either this alcohol group stays here, or it gets eliminated. So we either end up with the aldol addition or the aldol condensation, which occurs. Well, the question is whether or not we're underneath a condition which would make it favorable to do the elimination reaction between this OH group and this hydrogen. Well, there's two ways we can do elimination. One is under basic conditions. So if we have a strong base, because keep in mind this is a very acidic hydrogen sitting here because it is an alpha carbon, we will favor the elimination reaction. The other is if we have strongly acidic conditions. So if you go back to the formation of alkenes, we can do something like sulfuric acid. That's going to do a really good job of eliminating the OH group through a E2 mechanism. We go through the OH2 intermediate and we end up generating the double bond. It is only under neutral conditions do we favor the formation of this saturated aldol complex. Now, this is why typically when you'll hear me keep slipping up and saying aldol condensation when really I should be saying aldol addition and aldol condensation. Because if you're not under neutral conditions, you're generally going to end up forming this unsaturated complex. Now, is it cis-trans? And if you form this, is it RS? Well, this is where it gets kind of dicey. So when it comes to the cis-trans, well, really what's happening is that every single time you're going through this intermediate. So while you will form both cis and trans version of this complex, you're going to form the one that is more likely to keep the big groups opposite each other. So the majority product for an aldol condensation reaction in terms of that double bond is going to be one where the big groups are trans or E to one another. In terms of this complex, the aldol addition reaction, you're going to generate both the R and the S because that carbonyl there is trigonal planar. So it can go either way in terms of which way that OH group is going to go when it's finally formed. This kind of makes aldol condensation in terms of synthetic selectivity very difficult to do. You're going to end up generating racemic mixtures of R and S, and while you're going to favor the trans conformation, you're still going to get cis-trans mixtures. But that's the big thing with these types of aldol addition and condensation reactions. If you're not working under neutral conditions, you're going to get the condensation. If you're working under neutral conditions, that's when you're going to get the aldol addition product.